Good morning, and it's a Saturday morning here at C-Tech. It's already been exciting, which not important to this video, but let's get started with this. One of the things we're starting to run into as we enter the second quarter of our first semester here at C-Tech is we have welding students where we've been showing you how to read the WPS form now for several weeks, and we have students that are still coming up asking what amperage, what's the assignment, what do we need to do? So, this video, you need to respond to. You need to let us know that you've looked at it and that you understand some of the concepts for how to read the WPS form. So, here's our book. There's like 180 different procedures that we can program into the Vertex. But even when you're in the lab, we use the WPS forms to show you how to set up to start your welds in the lab, because you can use these as your base point to start with. Then you can adjust your amperage up and down. You can adjust your position based on what you're finding in the actual lab. All right, so here it is, page 1. So the welding procedure specification, that's what WPS stands for. There's information on here that you need to know how to find. First, what process are we doing? In this case, SMAW. Type, manual, means you're doing it, holding it by hand. The information up here in the top corner is just what's the identification number, when was it done, if there's any supporting documents, in this case Lincoln Educational, and it's got a document number. Okay. Joint design used. In this case, it's a single weld. This was, in case you don't know, the 60-10 whip that we did as our first assignment. Well, let me just work our way through here. Joint design. It'll tell you what kind of a joint it's supposed to be, if it's a single or a double weld, multiple passes, if there's any backing we've not gotten into. However, in many joints that we put together, we will put a backing plate centered on that joint. When we get there, we'll show you how to do it. If there's any root openings, this will become more important as we get into some of the more advanced work. What was our groove angle? Are we going to gouge it on the back? How will we do that gouging? Will we use a torch? Will we use a carbon arc unit? The material that we'll be welding on, in this case ASTM. This is the society that comes up with the numbers for steel. In this case A36, or just mild steel, mild carbon steel. The thickness of the material, 1/4 inch or 6.4 millimeters. Then our filler material. The most important thing you need to know is how to read for the welding rod that is desired, in this case E6010. It'll tell you if there's any extra shielding gas required, in this case when we get to the MIG or the TIG, or GMAW or TMAW, TIG metal arc welding, tungsten metal arc welding. The electrical characteristics, this has more to do with the top part, transfer mode. This has more to do with the MIG machine. Position, is it up and down? In this case, it's going to be flat on the table in position number 1. Power source, constant current, our current that we're using, AC. DC, electrode positive, or DC plus, or DC, electrode negative, DC minus. Power source, constant current or constant voltage. We've gone into that in some of our units that we've been through. Tungsten required, if any, in this case, none. Now, the technique. How are you to do the weld? Stringer, weave, bead, walking the cup, or other. In this case, they want you to do a whip stringer. So right directly across from the welding rod, it tells you the procedure to use. In this case, it's a single pass. Number of electrodes required. Well, if you're doing one bead, you should use less than one rod, although in this case it's undefined. Contact tip to work distance. This becomes important when we get into our MIG, flux core, and TIG welding. Peening, yes or no? Peening, just in case you're not aware, is, if you're familiar with the ball peen hammer, the round end is called the peen. What we do is, in some cases, when we're welding steels together, because we've introduced so much heat and stress into the weld, we can take that hammer and we can lightly tap or peen the weld area and release the stresses back into the metal. Interpass cleaning? No, you're doing one pass, so therefore you chip and brush it when you're done. How do you clean it? Chipping hammer, wire brush. If you need to do any preheating or interpass heating, interpass is between the passes. We may run a torch or some other device to keep the metal warm while we're changing rods and positions. Okay, down here at the bottom, of course, here is the illustration and the welding symbol that's telling you what is going on. Remember, in the welding symbol, we are one weld, and the welding symbol itself is on the arrow side. So arrow side means that you're welding on the side of the material that is closest to you. If the welding symbol is above the line, it means it's on the back side of the piece of metal. That's how a welding symbol works. So down here in the chart, this is the other part where people really need to look. You're doing one pass with a whip stringer, 60-10 rod, using 1/8 inch rod, which is pretty much what we have. You're setting it DC positive. Your amperage is 90, plus or minus 5. And then they have your travel speed, 13.9 inches per minute. If you have a 14-inch welding rod, you should burn one welding rod in 1 minute, plus or minus 10%. Because our coupons are only 6 inches long or so, you should use approximately half of the rod while you're welding. Now, in a whip, because it goes so fast in some cases, you may use less rod. But generally speaking, our base is that if you're dragging a rod across a piece of metal, you will burn one rod in 1 minute. And that's our base where we start from. So, let's look at a couple of these then that I have right here on the table. All right, so I have one here. So let's go through this. This is one that you guys have been working on in the classroom, in the lab. It is SMAW. It is manual. You're welding by hand. Now, in this case, our position, this is number 11 or 12. I don't remember which one it is, but it's one of the more advanced welds that you're doing as an introduction student. In this case, you're doing a 3F. Remember, position 3 is vertical. F is a fillet weld. We are just putting two pieces of metal together and we are welding them. That is a fillet weld. Fillet welds, butt joints, T-joints, corner joints, lap joints. Those are the ones that we use the fillet weld the most. Also, it tells you in this case that we are going to be going up. So this is a vertical up weld. We're going to be using 60-10 rod. We're doing a stringer. Now, in this case, it is 60-10. For most of our welds, 60-10 has been done as a whip. This time, it wants it as a stringer. You are just dragging it. Let's see, what else do we get off of here that we need to know? Oh, the metal thickness, 10 gauge. So we're using the thin metal that we have in the shop. So down here, we can kind of review. We're doing one pass of stringer for 60-10 using our 1/8 inch rod in DC positive, set at 80 plus or minus 5. And here is the weld, and in the illustration it is a fillet weld. That is a fillet weld symbol, and you're welding on the arrow side or the side closest to you, and you are doing, as you can see right there, one pass. And so what you'll do is you'll start at the bottom and you will work your way up. Okay, so that is how to read a WPS for that. I've got one more for you. This one's a little bit more complicated, but let's check and see what this one has to say. Again, this one is for SMAW in the manual mode where you're doing it by hand. We are constructing a T-joint. Oh, forgot that over here. Yeah, T-joint. Oh, they spelled that one out. T-E-E. No backing. It's a single weld. Okay, which again, we get down here, single weld, stringer. Okay. This one is in 7018. It is a stringer and a weave. It is up in the 3F position. Okay, so now let's go down here and let's look and see what they want. Well, we've got a stringer, we have a straight weave, and we have another straight weave. So we will have a total of 3 layers, 1 layer, 2 layer, 3 layers. All in 7018, all using our 1/8 inch rod, and all set to the same amperage of 125 plus or minus 5. Now, let's take a look at the illustration. In this case, you are running what is called a root. Pass number 1 is called the root. And in this case, look at this welding arrow. Welding arrow, we have 3 fillets in the same location. And you run them in this order, 1, 2, and 3. In this case, 1 will start closest to the corner, 2 will be next, and 3 will be the one that's coming out. All right, so in this case, you run a root pass. That is what the first pass is called. You're going to run it up. Then you're going to chip, quench, chip, and brush this. Then you're going to come in with number 2. Now, number 2 says it wants a straight weave. Now, a weave is kind of a zigzag where you're just manipulating the weld material to make sure that you have it bonding where you want it to bond and you're keeping the width consistent. Now, if the zigzag doesn't work, one of the other things that I have advised students, whether it's acceptable or not in proper welding circles, but it's just another way to manipulate it, is you can also do kind of a little horseshoe that goes up. Make sure everything is slightly pointing up, whether you're going vertical up or vertical down, because you are fighting gravity. Gravity wants to pull this off. But then you're going to make your second pass. The second pass will bond the base metal and the T, the upright part, and you're going to completely cover the root weld. So you're going to weld over the weld, but still welding these 2 pieces of metal together. You will then go and quench, chip, and brush. Make sure and get all the slag out, or you're going to have a massive slag inclusion, and that will just destroy the weld. And then we're going to come in and we're going to do our third pass. Third pass, same thing. We're just going to start here at the bottom, and we're just going to make sure and go over the other 2 passes, and we're going to have this huge, well, not so huge, weld that goes up all the way to the top. And then when we're done, what we should see, let me turn this over. What we should see when we're done, we should see a root weld. Okay, you're going to have done the root weld. We will have done the second pass, and we will have done the third pass. Okay, 1, 2, 3. When we turn this sideways, it should look like 1 weld has been dropped in there, when in fact you've done 3. You've welded the 2 pieces with your root weld. You've welded the weld to both sides with your second pass. And then you've welded the welds to both sides with your third pass. And that is what we are looking for. And regardless, remember in our other multi-pass that we did with 6010, I think it was number 8 or number 9. In that one, you did a root weld, and then it asked you to weld that weld to the base metal, pass number 2. Then it asked you to weld that to there, pass number 3, and we still should have ended up with something that looked like that. Regardless of how you do it, what we want to see at the end is we want to see something that looks like one continuous weld from one end to the other. So once again, what are we looking for? Last time. We're looking for how are we doing it? What is our process? What exactly are we putting together? Lap, T, butt, corner, edge. Although now edge is called a parallel joint. What is our position? Is it a groove or a fillet? In this case, it'll tell us 3F is fillet, 3G would be a groove. It will tell us up or down. It will tell us what rod we're using. It'll tell us what metal thickness that we're doing for this particular one. So 10 gauge, of course, is the thinner metal. 3/8 is our thicker metal that we have in the shop. It'll tell us how to set our polarity. DCEP is DC positive. Remember, our welders in the lab do not run AC. So DC positive is our default. DC negative is the other one. It'll tell us what we're doing. Whip stringer and then a weave. We're doing a multi-pass. Any more than one weld becomes a multi-pass. Will there be any special processes done? If there's any special electrodes we need, in this case it's just 60-10. And then of course come down here and pay attention to the illustration, and then pay attention to the procedure. It's telling you what to do right here. Whip stringer for the first one, straight weaves for the next two. Also tells you your amperage again and your polarity and what rod to use. So I would start here with the chart and then work my way back up through the WPS looking for any special information that I need. And that, very simply, is how to read a welding procedure specification, or a WPS.